Hey, I'm going to show you how to name ionic compounds. And naming is a language. It's a language. And like all languages, it doesn't always make sense, right? Just like in any language, sometimes you wonder, like, why do they do it that way? Why is this preposition and not that preposition? So chemistry is much more consistent than that, but you know, it's got some aspects of it that are somewhat similar. So, and I'll show you one or two of those as we go. But what we're going to do is we're going to take compounds that have a cation and an anion, so they're ionic. How do we know that? Because we've got a metal and a nonmetal. Metals from the left side of the periodic table, nonmetals from the right. In your brain, I'm not going to do this for every single step that I'm going to talk about, but you're going to have to break this up into what anion and what cation did I get. And I have a previous lecture on that, so definitely review that if you haven't done that yet, but check it out. Okay, so I got NaCl. I realize that they're made of sodium and chloride, and so I write sodium, and the first one doesn't change. We just leave it as its element name. We don't write chlorine. You write chloride, and you know, spelling is important, especially on the ending here. You mess up the name of the element, it's not always that bad. And there you're done. So most people get that one. Okay, so moving along, I'm going to do some of these kind of fast. You know, if you break this one up into two pieces, you get a couple different names. And if I was going to write a multiple choice test, I know that there's about 2 or 3 common ways people mess this up. This is the correct name. That's all you need. Now, you may ask, why not magnesium dichloride? And you know, that's actually kind of a good question, because the reality is that name kind of makes more sense to most people. Or you might say magnesium 2 chloride. And some combination of these two ways of doing it. I don't want to call them mistakes, by the way, because they're not mistakes. So the analogy I use sometimes is if I say, hey, do you want to go down to McDonald's restaurant and have a hamburger sandwich? That seems like kind of a weird thing to say. You don't need to say hamburger sandwich. It's just assume you mean a sandwich. But maybe you mean somebody from Hamburg, Germany. And if you say you're going to McDonald's, do you mean the McDonald's hamburger place, or do you mean my friend John McDonald's place? Right? So including the Roman numeral 2 or the letter word di is kind of like saying extra words that you don't need. When a chemist sees magnesium chloride, he just says to himself or herself, hey, you know, chloride, that's -1, magnesium, that's +2. Everybody knows that because that's from group 2 on the periodic table. And if you go back to that previous video, those are the ones you're supposed to memorize. Magnesium is your friend, always group 2. Chloride, always -1 when it's by itself. You don't need any more information than that. Reality is, every once in a while, like if you look on shampoo bottles, you'll see this one as the ingredient. So it's not like it's crazy wrong, but especially online homework programs will mark you wrong for that, and they'll say it's not correct. So, you know. Don't feel bad if you wrote that down. It's really not as bad as you might think. It's not like wrong. You know? So again, for this one, you don't call it disodium oxide, because the idea is that everybody knows that sodium is +1, which is of course not true, but that's the assumption that the language makes, that you know that. So sodium oxide. Oh, and as a quick tip, online tests are tough to write, because if somebody gives me a funny answer that maybe I didn't think of, you get marked wrong. If this was done on paper, I can, you know, be lenient and say, oh, I see what they were doing, and go ahead. So, you know, try to be careful when you're answering questions. Okay, this next one down, NaNO3. Again, from memory, you get Na+. That's in the first column of the periodic table, alkali metal. And then you say NO3, what's that thing? Well, if you don't know it, you can figure it out, because you can say sodium is plus, nitrate must be minus. Again, covered that last video. Or you can memorize that, but you do have to memorize what is NO3 minus. You know, that comes from memorization, and that is sodium
nitrogen becomes nitrate.
So in this case, if you called it sodium nitrogen trioxide, that's flat wrong. That is just like a really weird name. You don't just get to list all the elements in order, like turning the formula into words. That's not how it works. Okay. Oops, sorry. Pause for a second. Hey, little recording problem. Okay, get back to this. So the next one up, we got CrO3, and Cr is chromium, and you know, might have to look that up. So we got Cr, I got 3 oxygens. I know that each one is -2, so chromium must be +6. So process of deduction or something like that. Here, this is not an acceptable answer. Because if you gave that name to somebody, would they be able to go backwards and get the formula? No. Because they would know chromium, they would know oxide is -2, but they'd say chromium, God, what's chromium? Is it 2, 3, 4? I don't know. They'd look it up in that chart, that table, and they'd say, oh my gosh, it could be lots of different things. I don't know what it is. So you need to tell the person what it is, just like a language, we're trying to communicate with each other. So chromium is +6, so we write a little Roman numeral there for 6. And remember, that Roman numeral means what's the charge, you know, on that. So that's the charge on this thing. The mistake you get sometimes is people will write, for this answer, they'll say chromium-3 oxide. Chromium-3 oxide. And they'll think the 3 means that there's 3 oxygens. No, don't do that. So don't call it that. So the best name is chromium-6 oxide. However, if you were going to actually, if you were actually to go buy this stuff, you will very often see it actually in the real world sold as chromium trioxide. And this is an example of what I mean by language sometimes being tricky. So, you know, you can learn what's considered like proper chemistry translation, and like you'll call it chromium-6 oxide. That's the correct name. However, many people will just give it a new name. They'll call it chromium trioxide. And so sometimes if you especially if you look it up on Google, you'll see the name chromium trioxide, which is not the correct name. Sometimes companies just sell it that way, or it's an older name that's stuck around, and we're lots of examples like that. So we're going to use the proper naming and do it the right way. Okay, so kind of move along. Here I got my iron. I got 2 of these things. Here's an example where if this was a an exam, and you don't know either one of these, if you don't know nitrate's charge, and you can't figure out iron's charge, you're not in a good way, right? So you really need to at least have that part memorized so you can figure out that the iron is +2. So the iron is Roman numeral 2. That tells you the charge, and nitrate. And if you think about it, what we're doing is we're just turning this word, that symbol, linking them together. The word iron 2 is just like iron +2. So the symbol just becomes a word. That's it. You don't call it dinitrate. You don't need to. We already know that. Okay. Next one down, CO3. You've got 2 sodiums here. You probably could figure out that that's -2. Got your sodium, and your carbonate. And doing pretty good. So next one down, NaHCO3. We got a little bit of a split here. I got sodium and an H. CO3, 2-. There's a couple different ways of writing that ion. You could mix the H in and call it by its name, hydrogen carbonate. Or you could draw it like a cartoon like that, just a mental picture. So you could say and there's actually 3 separate words here: sodium, hydrogen, carbonate. Why not alphabetically? Because it sounds better. Sodium hydrogen carbonate. Another way of naming this, and this is acceptable if you give me this answer, is to call this a bicarbonate, and you'll see that from time to time. And that's actually more common, but chemistry people will call it sodium hydrogen carbonate. Next one down, sometimes beginners will call this one dipotassium sulfur trioxide, ooh, which I love is a complete guess, but it's totally wrong. So what happens with this one is people will call it potassium sulfate. So close, so close. So you have potassium, not dipotassium. Sulfite, right? So that's one of those kind of tricky ones. Either memorize it or look it up. So moving along, and this one is sort of similar to the chromium one I did earlier. This one has quite a few different names. First of all, how you pronounce it and how you spell it, or if you're English, they actually, we spell it apparently, well anyway, you can call it aluminium. All right, sorry, I got a little phone call there. So you could do aluminium, aluminum. I'm not getting into that whole thing. Anyway, that's a little dialect thing. However, so we got aluminum chloride, aluminum trichloride, or aluminum 3 chloride. And this is actually an interesting one to me. What's the best answer? Not just, and now someone will say, well, what's the right answer? Well, it's a language, so sometimes people say things in different ways. The textbook answer is the first one, aluminum chloride, right here, and that's considered to be always correct. If you went back to that chart of naming from a previous lecture, back up to this, that I gave a little while ago, you would see that aluminum, is always +3. Zinc and silver and cadmium also having kind of that same idea. They're always +1, +2, +3. And so some instructors will tell you, don't memorize that. You don't need to put down, sorry, you should memorize that. Don't put down aluminum 3. And then you'll say, this is incorrect. So I will mark, I'm going to say it's, it's not correct. Aluminum 3, not supposed to put it down, but it's not really that bad. If you write, earlier when I said if you write sodium 1 or potassium 1, don't do that. But it's not wrong. It's just kind of extra stuff that maybe you don't need. Commercially, when you buy this, it's always sold as aluminum trichloride. I have looked it up before. You will almost never see it sold under aluminum chloride. Right? So this is an example where if you look things up, sometimes it'll be different than what textbooks will tell you, which is kind of interesting. As a little side note, if you answered a question like this with parentheses, x times y, and your final answer was like that or something, are you wrong in an algebra class for putting down extra parentheses? Really? No, it's fine. So putting the one or putting the extra number in here is a little bit like extra parentheses. You don't need it, but we leave it off. So, okay, next one down is we got this kind of funny group. Now here we have a bunch of stuff in the front, and there's 2 of them. And if you remember that group, it's kind of obscure because it's the only polyatomic cation, positively charged. Right, there's 2 of them, and then there's carbonate. So that one's going to be ammonium carbonate. So if I ask you, is that an ionic compound? You'd say, yeah, there's a cation and an anion. And if I say, where's the metal? There's no metals. So this is all nonmetals, yet it's still ionic. So you know, chemistry has lots of weird exceptions in it, and this is one of them. So ammonium carbonate. You don't have to call it diammonium, because we know that carbonate has -2. Okay, well, last couple ones are going to be like the trickiest ones. Sometimes these get a little hard to do. So I'll talk more about acids perhaps a little bit later. Here we got H plus, you got NO3 minus, and lots of times people will write hydrogen nitrate. And I will give that a meh face. I don't love that answer, but I would not mark it wrong if it was asked that way. But what if I ask it instead this way? And I put that little AQ down. And that AQ means aqueous or aqueous. It means it's been dissolved in water. How does the name change? Some people will write hydrogen nitrate aqueous. Good luck, but I like it. This is called nitric acid. And what I'll do is at the end, I'll just write out all the acid names. I honestly think it's just easier to memorize all the common acids than it is to try to remember a rule, but there you go. So if there's an H in front, it's always okay to name it as an acid. You can get away with not doing it that way if they forget to put aqueous down, like HCl, this next one. You could call hydrogen chloride, but almost always it's going to have AQ because they want you to write the name of the acid. Hydrochloric acid. And it's kind of like an irregular verb. I think it's best to just memorize it. So I'll write those down in just one second. Got the last one of before I do the acids. This part, not so bad. I'm recycling that one from before, and then just 3 waters. So how do you now, if I said sodium carbonate, 3 waters, that sounds kind of weird, right? I don't like that. So I'm going to not write 3 waters, but I'm going to sound science-y, and I'm going to write trihydrate. And now you're talking chemistry because we put it into Latin. There you go. That's the name. Sodium carbonate with a space, then trihydrate. That's all one word. Okay, quick thing on the acids. Generally speaking, if something ends in the word ate, then it becomes what's called an ic acid. If it ends in ite, sulfite, nitrite, it becomes an us acid. And I think it's best to just see examples. So NO3 minus, nitrate, HNO3, nitric acid. SO4, 2 minus, sulfate. Add 2 hydrogens to balance out its charge. Sulfuric. Now, so the first thing about that rule is they add that UR in there because sulfic acid just sounds funny. And there's no other reason than that. They just tacked on those little extra words, extra sound, just to kind of make it sound better. Carbonate. H2CO3. They had a couple H pluses to balance that out. Carbonic acid. And the last big one. Now here we need 3 hydrogens, right? Because it's phosphate has a 3 minus charge. And so in that case, we've got phosphoric acid. Okay, now, what would the names be if I took away 1 oxygen from all of them? Well, just like with nitrates, I take away 1 oxygen, they all become ite, nitrite, sulfite, carbonate. Well, there's no carbonate. Phosphite. So if I took away an oxygen from that, I would end up with HNO2, H2SO3, H3PO3, and this is nitrous, spelling today, nitrous acid, sulfurous acid, and phosphorus acid. none of these are very stable compounds, and they tend to be intermediates that are formed very briefly in some other reactions. These guys, the nitric, sulfuric, carbonic, and phosphoric, big four, super common. Biology, mining, geology, chemistry. Anytime you're talking about chemicals, they're going to show up. The sulfuric acid is one of the most commonly made industrial chemicals in the world. So it's a shocking amount of the stuff is made every year. Okay, last bits are these guys, HCl, HBr, HI, and HF. Whoops, did those out of order. HF is first. Hydrogen fluoride becomes hydrofluoric acid. Hydrogen chlorine becomes hydrochloric acid. So in these cases, memorize them. I think it's easy. These are sometimes called mineral acids for reasons that aren't very clear, but mineral means that there's no oxygen present. It's very important. And so, yeah, the little spelling thing, it's OIO, which is kind of weird. And fluoric is not fluoric. People misspell this all the time. And sometimes they'll get it wrong on online programs. That's like pancake flour. Fluoric is FLUO, so it's really goofy because it's a strange letter combination. Wow. So that's a lot of stuff. The secret to naming is I can take, any cation and any anion, glue them together to make a compound, and then the name just comes about from knowing the names of each piece. Going backwards, a little bit tricky. I might have a separate video for doing that. Anyway, it's already a bit long, so good luck, everybody. Hey, sorry about that. Some of that got cut off. The last bit of naming was for the mineral acids, and you have hydrochloric acid, hydrobromic acid, hydroiodic acid, hydrofluoric acid. So I think they're just worth memorizing. You can try to remember a rule like chloride becomes an ic acid, but I don't think it's necessary. The acids that I've covered are the big ones that you need to know. The one that crops up a lot, especially later for people moving on in chemistry, is this one. If you remember this thing, this was acetate. So what would the acid from this thing look like? What would I call it? And you think sulfate became sulfuric, carbonate, carbonic, right? So acetic acid. Acetate becomes acetic acid. And all the organic ones will also have that same kind of flavor. It could be blah, 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 8. It'll become blah, 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 ic acid. All right, everybody.